In this chapter, I'll demonstrate a simple circuit for detecting the presence or absence of water with an Arduino using an inexpensive water sensor. Okay, and over the next few slides, we'll go over the parts and build for this simple circuit. Obviously, you're going to want an Arduino Uno, and a small breadboard also helps. A USB cable type A male to type B male, some male to male and male to female jumper wires, a water sensor, of course, an LED, and a 270 ohm resistor. And I have included links where you can purchase these parts online in the description of this video. And once you're in possession of all those parts, this slide summarizes how you're going to want to wire everything up to your Arduino Uno. And I'll pause here briefly just to note that when you're ready to insert the LED in the breadboard, make sure that the longer lead on the LED is associated with pin 8 on the Arduino, and that the shorter lead is associated with the ground end of the circuit. And when you're done, you should have something that looks very similar to this. The code for this demonstration is fairly simple. We're just going to monitor our water level sensor via analog pin A0 on our Arduino. If the pin registers a signal greater than 400, which is about 2 volts, then we inform the Arduino that water is present. Our code then allows pin 8 to pump some current through our LED and write the flow on text to a serial terminal window. Let's walk through this. First, here's pin 8, which we have defined as an output pin or a current valve that we can open or close for the purposes of controlling our LED. We're also using pin A0, which by default is set up as a sensor or meter for measuring the voltage from our water level sensor. Since A0 is input by default, we don't need to define the same in our setup block. Now let's walk through our loop. The first thing we do is check the signal on our analog pin. If our sensor is in the presence of water, then our conditional statement here will register true. This will set digital pin 8 high, which in turn will open the valve for electrons to flow through our LED, and also prompt a message to our serial terminal that tells us that the flow is on. If our sensor is dry, then the else statement of our conditional kicks in. In this case, the valve on pin 8 is closed and our LED turns off. Also, we'll update the message to our serial terminal to show that flow is off. Okay, so my USB cable is connected to the back of my computer. I'm going to take the other end and we'll try to do this one-handed here. And of course, we want to plug this in to our Arduino. And you can see here that the little green light next to the on text indicates that everything's powered up. So we're good to go. We're ready to upload our sketch. So the next thing I'm going to do is start up my Arduino software. And this takes a few seconds. Great. The software recognizes the last sketch that I opened, which is the one we've been talking about. It's the simple sketch for sensing water. So the next thing I want to do is look under Tools, make sure that I've selected the right board, which is an Arduino Genuino Uno. I also want to make sure that I select the correct programmer, which is an AVR ISP. And then I want to make sure that I'm set on the correct port. And here I can see that my Arduino Genuino Uno is on this port right here, and there's a check mark next to it, which is what I care about. So the next thing I can do is go ahead and verify that the sketch will compile correctly by using this little checkbox right here. It says done compiling. So the next thing I can do is upload it to my hardware. It says uploading, done uploading. So this sketch that we've been talking about is now part of my hardware. Okay, so I've migrated my setup into the garage where it's a little safer to play with water. I've got a serial terminal hooked up, and you can see that it's reporting that flow is off because my sensor's dry. Let's go ahead and dip that in the water, and now that's going to generate a voltage increase on that analog pin, which is going to result in that LED being turned on. And now you can see that my serial terminal is reporting that flow is on. Now let's go ahead and remove that, shake it off, And as a result, the LED now comes back off. And if I check my serial terminal, now it's saying that the flow is off. Pretty simple little circuit. In our next video, I'll demonstrate how we can log the results of our simple water detection circuit to a data logger to include a timestamp of when flow was detected or absent. Stay tuned, and thanks for watching.